Hi everyone, it's Amy from the ACT Education Directorate's Academy of Future Skills team. Thanks for joining us for National Science Week 2022, where we're exploring glass. Every day we look through it, but have you ever stopped to wonder how glass is made? These grains of sand are made from quartz, which is also made up of silicon dioxide, or silica. And when we heat them up to extremely high temperatures, they are transformed into glass. As it turns out, there's also a range of ways that glass can be made in the natural world too. Today I'm here visiting our friends at Geoscience Australia to find out a little bit more. Here we are at Geoscience Australia, and I'm joined by Joe, who's going to talk to us a little bit more about how glass is formed. How are you today, Joe?
Yeah, really good, Amy. Thanks for visiting us here at the Education Centre.
No worries at all. We're absolutely delighted to be here. Now, Joe, I understand that glass is formed by quartz, but can you tell me a little bit more about how this process actually happens?
Sure. So quartz is a mineral and rocks are made up of a collection of different minerals. We can see feldspar, we can see mica, and we can see quartz, which is the mineral that makes up glass. Now, many of you might be already familiar with the mineral quartz and might recognize these beautiful quartz clusters here, where you have these nice pointy crystals. Now, quartz can form in many different shapes. It can form in many different sizes, and it can also be lots of different colors. But when rocks containing quartz are broken down by weathering and erosion, the minerals inside can get smaller and smaller and smaller and smaller until eventually we are left with grains of sand.
I sort of understand this process of weathering and erosion, and I've often thought about it when I'm at the coast and I'm looking up at the cliffs and watching the waves just wear away those bits of rock. And it's amazing to think that these small grains of sand were once part of something much larger.
Yeah, absolutely. And liquid water plays an extremely important role in wearing down rocks. But ice and wind and other chemical processes can also break down rocks. And the sand that is eventually formed can accumulate in certain environments. For example, in an ocean, in a river, on the beach, or maybe even in sand dunes. And it was humans many thousands of years ago that actually discovered that if you put those quartz sand grains in a really hot fire with a few other chemicals, you can melt those quartz grains quite easily to form the substance we now know as glass.
Really interesting that humans made this discovery and could make glass themselves, which has helped us out in so many different ways. Now, Joe, I also believe that there are quite a number of natural ways that glass can be made, and you're going to share some of them with us today.
Absolutely. I've got 3 ways that glass is made naturally in the environment, but it is important to remember that glass is formed under really hot temperatures. So some of the natural ways we can get these really hot temperatures is through lightning strikes, volcanic eruptions, and meteorite impacts.
All right, glass made from lightning strikes. That sounds pretty spectacular. I'm curious to find out a little bit more.
So basically, through sheer luck, a bolt of lightning has hit a beach made of quartz sand. And in the exact location where that lightning bolt hit, the little quartz grains melted and formed a glass. And the structure it forms is a fulgurite. And these are really interesting because they actually track the course of the lightning bolt down through the sand. Now, many of you may observe that we can actually see these sand grains on the outside of the fulgurite. That's because when the glass melted, it was hot and some of the grains actually got stuck on the outside. And then some lucky person would have been walking along the beach and they just would have found the fulgurite sticking out of the sand. Pretty amazing.
Isn't that fascinating? You can literally see the path that that lightning strike took.
Yep.
All right, so we've heard about glass made from lightning now. I believe that I know the name of glass caused by volcanic eruptions. Is this one obsidian, Joe?
Ding ding, that's correct. Yeah, no, it's actually one of the favourite specimens that we have here at Geoscience Australia for the students who visit us, because obsidian is used in the game Minecraft. Now, obsidian is volcanic glass. Now, as we talked about before, glass needs a high silica content to form. So the molten material that this obsidian was made from must have a high silica content. So during the volcanic eruption, the lava that is spewed out of that volcano cools instantly. It cools so quickly, a beautiful glass is formed.
How interesting, and it's so good to finally know a little bit more about how obsidian's formed. What else can you tell me about this particular specimen, Joe?
So in this specimen, and actually many of the specimens of obsidian we have here, you might be able to notice that there's this amazing pattern here. There's many lines, concentric lines here, and it might remind you of the pattern on the outside of a shell. This is what we call a conchoidal fracture. So when the obsidian is hit, it breaks off, and along the edges of these breaks, we create incredibly sharp edges. And it's this property of obsidian that was used by many different indigenous communities all over the world to create weapons and cutting tools.
All right, now you mentioned earlier, Joe, that there is a type of glass caused by meteorites, and I am so keen to find out more. Please tell me about this.
I'm glad you're excited, Amy, because it's actually my absolute favorite type of glass. Mostly because of the beautiful story that we can tell. Here we have a tektite. And if these tektites happen to be found in Australia, we can call them australites. Now, these australites have an absolutely incredible story. An enormous meteorite impact occurred somewhere in Southeast Asia, and at that exact impact site, the rock on the ground actually melted. Some of that melted rock splashed up into the atmosphere, and some of it even reached space. And because that melted rock cooled so quickly, it instantaneously formed glass, just like the obsidian we spoke about before. Now, that glass actually started to fall back down to Earth. And as the australite fell through our atmosphere, it started to heat up and melt again. And the shape of the australite started to change. And in some of the more extreme cases, we get these beautiful button-shaped australites form. We might be able to observe, by looking closely, that we can see the actual ripple marks of the glass melting, frozen in time for us to see and study today.
I can absolutely understand why this would be your favourite type of glass, Joe. What an amazing story. These little pieces of glass have literally been on an out-of-this-world adventure.
So these tiny space travellers achieved something that humans had long dreamed of. They started on Earth, they made a trip to space, and then they made it safely home again. It's this beautiful story that sparked the interests of many scientists. So much so that scientists from NASA actually started to study these australites because they wanted to learn a bit more about the shape and the chemistry of these little bits of glass and use that to inform how they build their re-entry spacecraft to bring astronauts from space back to Earth safely to their families. It's pretty wild, pretty exciting.
I cannot believe that these tiny bits of glass were so important in designing spacecraft. It is amazing when we can look to nature to inspire some of our best developments in science. Thank you so much for your time today, Joe, and for sharing with us some great examples of how glass can be formed in the natural world.
You're very welcome. Thank you for visiting us.
What an amazing opportunity to explore the natural ways that glass can be made, from lightning strikes to volcanic eruptions and even meteorite impacts. Thanks for joining us as part of National Science Week 2022.